Hey everyone, thanks for joining. Welcome to today's presentation. We're going to talk about building a hybrid data pipeline with Kafka and Confluent. My name is Josh Treichel. I lead Partner Solutions Engineering at Confluent. I'm excited today to be joined by Sarthik from GCP. Both Sarthik and GCP have been great partners to us over the years. So Sarthik, please introduce yourself and take it away.
Awesome. Thanks, Josh. And thanks everyone for joining. As Josh mentioned, my name is Sarthak. I'm a partner engineer for Google, for GCP, for North America, and I work pretty closely with Josh on designing these architectures and solving these customer problems. So first, we're going to spend a few minutes understanding the agenda. So we are going to first talk about what's the exact problem statement which we are trying to solve today. What is Apache Kafka and what is Confluent? We are hoping everyone in this audience is familiar with Kafka, but this is just we're going to brush over it. We are going to then talk about how to build hybrid data pipelines using Kafka and Confluent. And finally, we are going to look at some of the common use cases, common design patterns, which our customers have implemented in production and are having great success while doing this hybrid data pipeline. One business problem which we also see in our personal lives, which probably all of you can relate to, is the total volume of data which is getting produced and consumed every day, both at an individual level as well as an enterprise level, is increasing tenfold, right? And also the window of opportunity when you can actually take the data and take business insights, helpful business insights, is reducing drastically. One example of that is happening all around us with COVID and coronavirus and all the aftermath of that, from economic, political, business, competitive landscape, which is changing every day, every week. Now, with a tremendous increase in volume of data from a business standpoint, if you have to make a decision on how to best adjust your business, both at a larger organization level, as well as a lot of smaller tactical project level and everyday decisions level, your window of opportunity is really low. It's probably a few hours or a few days when you have to actually process the data and understand how best to take actions based on the data. If you look at over the last decade or so, how this industry has kind of evolved, it is primarily around batch data, right? Where a large volume of data gets collected over the day. Only a small amount of data is gets used during the day. Other data is kind of uploaded through an FTP or other technologies for a nightly job or a weekly job, and then it is kind of processed offline. Oftentimes what happens is because of the batch nature of the analytics data, the business decisions what you will take kind of lags by a huge margin. We have seen, for example, the fraud detection risk scenarios we have seen in many banks. It takes weeks, even months, for them to determine whether a particular transaction or a set of transactions were fraud, or whether a set of transactions have correlation to determine whether it was a fraudulent transaction or not. In today's world, more and more organizations are trying to take these decisions in more near real time. So they're trying to capture opportunities from things like market trend analysis or user behavior tracking. Like when a user for a retail is coming on their website and our mobile apps, you want to kind of try to predict their behavior and provide more relevant suggestions and recommendations and so on and so forth with as near real time as possible and not based on what the user did a week back or 2 months back. And similarly, even in case of reduction of risk, other than fraud detection, from bad actor identification, and a whole bunch of other use cases, lot more and more enterprises needs to take these decisions in near real time. So with that challenge in mind, a lot of times the customers come to cloud and to GCP and try to leverage some of the analytics capabilities and AI/ML capabilities and the serverless analytics which GCP is awesome at, and try to see how can we leverage those Google capabilities to actually solve those problems in real time. And but when they look at their on-prem system, one thing which kind of stands out in a lot of times is they might be heavily invested in Kafka. Hopefully, all of you or many of you are familiar with Kafka. Kafka is a messaging platform. It is for PubSub. It is a PubSub. It is extremely scalable messaging platform. The whole idea of messaging and publish subscribe is nothing new. This has been there from the good old days of JMS to MQ. It has seen many incarnations. Coming out of LinkedIn in I think in 2011, coming out of few smart software engineers over in LinkedIn, what Kafka did, it kind of reinvented the whole world of public subscribe and created this system which is infinitely scalable, extremely fault tolerant, which can scale across multiple servers, multiple data centers, multiple geographies, and it had this way to store all the data infinitely in the form of logs. So it kind of created this brand new architecture on how PubSub should work, and which landed extremely well as the volume of data kept increasing on-prem. So a lot of enterprises are have actually standardized over the last decade or so under Kafka, especially it is backed by Apache. It has kind of become the backbone or how all the discrete systems are kind of coming together in the enterprise data center. So what we thought we'll try to talk about today is how can you leverage your existing investment in Kafka and try to use that to do these near real time, near real time use cases on GCP. So this is exactly what hybrid streaming is trying to solve. That using GCP plus Confluent and the Confluent Cloud specifically, which we are going to talk about a little later, how can you actually move this data from your on-prem systems, from your existing Kafka without changing anything or minimally anything, and move the data to GCP and start leveraging the world-class serverless, no ops, extremely scalable and extremely powerful analytics platform which Google offers across products like BigQuery to Dataflow to Looker and everything else. Right? So I'm going to hand you over to Josh, who is going to kind of walk you through about what is Apache Kafka and what is a distributed event streaming platform and how does the whole thing kind of fits into this vision of cloud. So with that, over to you, Josh.
Thanks, Sarthik. I think Sarthik did a really good job describing the need for real-time data, giving some background about Kafka. And I think, right, I'm expecting that many of you have at least heard or know about Kafka at a high level. I'd like to just take a little bit of time to talk about some of the key features of Kafka that we think really differentiate it and make it a streaming platform rather than just pub sub messaging. So Kafka is most widely known as kind of the de facto pub sub messaging platform. It is highly distributed and has a ton of different use cases throughout organizations. What people don't know is that, or might not know, is that Kafka also stores data. So similar to HDFS, Kafka stores data replicated in a durable way, and you can store as much data as you want. So you can store an infinite amount of data on a Kafka cluster. Kafka also allows you to process data. So via Kafka streams, KSQL, or even single message transformations in the Kafka Connect framework, you can interact with the data in real time as it's moving through. On that last slide, I mentioned Kafka was an event streaming platform. I think a lot of people aren't familiar with the term event streaming or probably think like, why did you create a new term? We already have kind of existing terms for data infrastructure. And we think that kind of with this new age of data and how businesses are starting to build their business around streaming and real time, that it does matter, and there is really this new paradigm shift towards real time event streaming. And so we created this new phrase, and in this, it really has four requirements to it. So it's built for real time, it's scalable to all types of data, it's persistent and durable, and it's capable of enrichment. So you can interact with the data as it's moving through the system in real time. And there are other existing data infrastructure tools out there that provide a lot of these, but they don't really provide all of them. So you could put together a number of different systems, or you could use Apache Kafka and Confluent and get the best of breed event streaming platform. Some of the key pieces of event streaming, and specifically for this hybrid streaming data pipelining we're talking about, is being able to connect systems together. And in Kafka, the way you connect systems is via, aptly named the Kafka Connect framework. So Kafka Connect provides a framework to easily build connectors. The ecosystem is built over 100 different connectors to different systems, so I can pull data from pretty much anywhere and I can push data to pretty much anywhere. And while that data is in Kafka, I can interact with it via something called Kafka Streams. So Kafka Streams is a Java library to do stream processing within the Kafka ecosystem. On top of Kafka Streams, we've built KSQL. KSQL is a SQL syntax that's an abstraction layer on top of Kafka Streams. So for non-developers, you're able to interact with these streams of data in real time. So with Kafka Connect and Kafka Streams, we're able to really simplify data architecture. So instead of having, tens or hundreds of systems that need to talk to tens or hundreds of systems, we can move data through Kafka. We can interact with that data with Kafka Streams. We can transform it. We can merge streams, and then we can push those streams to the systems that really want, like BigQuery. Pull the data from data to Dataflow, push it to GCS. Now let's think about this more from a customer's perspective, right? So what would this look like in the real world? So if we look on the left, we have a very simplified view of some data infrastructure, right? We have a bunch of applications. They look like microservices applications that are communicating via a Kafka in an event-driven way. Some of those applications are directly communicating with some data sources. We also have data lakes and other databases that are connecting to Kafka, pushing and pulling data, maybe creating materialized views in Kafka for those applications to read. And that's on-prem or in some other cloud, right? And then we have where people want to go, right? Like the world's moving towards the cloud. GCP has world-class analytics, so we want to, as a customer, take part in the streaming analytics. So I'm going to let Sarthik kind of talk about how we can connect these two worlds.
Thanks, Josh. Um, when we talk to a lot of time our enterprise customers, oftentimes their journey they want to start with Google's world class analytics. Their desire might be to start with GCP to use BigQuery because you can now process massive amount of data much faster. Because you might want to use big sheets to connect the data into Google Sheets and process in a more business friendly way, or you might do awesome visualizations using Looker and so on and so forth. Now, what do you see on the right hand side? This is a pretty representative architecture of what that data pipeline on a GCP might look like. First on the left, you have PubSub, which is Google's own version of PubSub and a messaging platform. This is serverless, extremely fault tolerant, extremely geo-distributed Google native PubSub, which is very heavily used inside Google. And a lot of customers use it, and this is typically what their starting point is. So they will dump the data in, and then the data can get picked up by another subscription PubSub topic, and then flows through Dataflow, where there is a processing, store the data in BigQuery, which is Google's extremely scalable, no ops data warehousing tool. And then finally might do some visualizations using Data Studio or Looker. On the other hand, you might also want to take the same data, process it through Dataflow, and then store it in GCS in storage using in file formats like Avro or Parquet or whatnot. Keep in mind, this is a very representative architecture. There can be a lot of variations from instead of data landing in PubSub, it can land into GCS, or instead of just doing visualizations, you might want to trigger actions using Cloud Functions based on the data in BigQuery, or you might want to use AIML, use BQML for that matter, BigQuery ML or the ML engine in Google. Now, as Josh mentioned, that this is always kind of the desired state, right? Like this is the high level data pipeline which you want to go towards, but your reality is what you lies on the left, and especially if you have invested in Kafka. So what we are trying to see is how can you actually leverage those existing Kafka infrastructure in pushing the data to PubSub. So the way customers typically do it today is PubSub has an SDK, PubSub has REST APIs. Using those, they can actually push the data from the different applications and the data stores and mainframes and whatnot to PubSub. And then from PubSub, it can start all those data pipelines. Though this works, the challenge with this is depending on how complex that on-prem ecosystem is, you might need to have include that SDK into so many different applications and deploy it in production. And that itself can be a daunting and a pretty complicated project, especially if you have technologies as old as mainframe, AS400, so on and so forth. So what we started to look at is if an enterprise have already invested in Kafka, how can we actually leverage that to make that journey a little better wherever possible? So Confluent Cloud, which is available as like a first party service on GCP, it is available directly through Marketplace with direct integration of billings and support and integrated with Google IAM, networking, and all that kind of stuff. They have this awesome capability called Confluent Replicator. So if you are using Kafka, you can then leverage the replicator capability feature from Confluent on top of that and replicate the data pretty easily from on-prem to GCP. Now, all your existing systems are already pushing data to Kafka, so you hardly have to do anything. And then the data, once it comes to GCP, then the same data pipeline which we talked about earlier can be triggered on, and then the data can go into all its different paths from visualization to cloud functions to data studio and so on and so forth. I'm going to hand it over to Josh now, who is our Kafka and Confluent expert, to walk you through what exactly is Confluent Cloud and Replicator and KSQL and all these cool technologies which you see on the screen. Josh, over to you.
Cool. Yeah, I think Sarthik did a pretty good job of describing Confluent Cloud and its tight integration to GCP. The idea here is really that for existing Kafka users, we're trying to simplify and ease their adoption journey to the cloud. And so, as Sarthik mentioned, there's a bunch of different ways you can do this. There's a number of you could go point to point from a database directly to BigQuery. But we think that for Kafka users, since Kafka is oftentimes kind of the way that those systems connect, that tapping into that existing Kafka infrastructure, creating that persistent bridge, that real-time bridge to the cloud, and then being able to integrate directly to GCP first-party services, start building applications with the data from on-prem in the cloud is really compelling. And so Confluent Cloud, as Sarthik mentioned, it's a fully managed service. And so this makes the journey a bit easier, right? So you're not having to manage Kafka on-prem and then manage Kafka in the cloud. We take that burden away from you. I wanted to talk a little bit about the two components on that last slide, Confluent Cloud and Replicator. So Confluent Replicator, on that slide, it looked like it was actually kind of part of both of sides of that, right? So it was part on-prem and part in the cloud. It's actually part of the Connect framework, or uses the Connect framework, and is a connector. It's a complicated connector that has a bunch of cool stuff that makes it super resilient. But it's a connector that either runs on the origin cluster or at the destination. So it's either pulling data across a network or it's pushing data across the network. Typically, we have it pull data, but you can run it in either pattern. And so this Confluent Replicator allows us a really nice, clean story to tap into existing Kafka infrastructure without really having to touch anything, right? So we don't have to go touch those databases. We're only hooking into the existing Kafka installation on-prem. In Confluent Cloud, as Sarthik mentioned, it's a fully managed service. If you've ever managed Kafka before, you know it can be challenging, right? So it's a distributed system of Kafka brokers. It's a distributed system of zookeepers. Kafka Connect is a distributed system, and so there's a lot of complexity here that we hide from you. So you don't know how many brokers there are. You don't know about Zookeeper. When you run the Connect framework, this is from a UI where you just point and click. So we think that this is a whole new way to run Kafka, kind of a cloud native Kafka that's super compelling. And it's not just Kafka that we're running. We're running schema registry. We're running KSQL. As I mentioned, we're running connectors for you. So if you want to connect to BigQuery, you don't have to figure out how much data you're moving there. You just go to the UI, say you want to connect this topic to BigQuery, and it starts moving. And then we allow you to store as much data you want as on that Kafka cluster as you need, right? So you can store an infinite amount of data in those topics. So adding these two features, if we take a step down, right, from the more architecture slide, if we think about existing customers that have on-premise Kafka infrastructure, whether it's open source Apache Kafka, Confluent Enterprise, right? So they can use Confluent Replicator, they can run it on-prem, they can run it in GCP, and now they can create this real-time stream of data to Confluent Cloud. Once the data is in Confluent Cloud, take advantage of those fully managed connectors and just start pumping data into the services that they're most interested in. They can also have applications that start directly integrating with Confluent Cloud, right? So building microservices in an event-driven way and using Kafka as the mechanism to do that is super common pattern. So now you can have Confluent Cloud there as your event-driven microservices Kafka. Let's talk about a couple use cases here. To start, right, just wanted to talk about like the fact that this is a super kind of simple horizontal use case that can be used practically for anything, right? As Sarthik mentioned earlier, any use case where you need real-time data that doesn't live on GCP, this is pretty well suited for. We're taking advantage of the fact that something like, it's something like 75% of Fortune 500 companies already run Kafka. So the assumption here is that that can be a vast source of data that we can easily tap into and start creating this real-time data pipeline. Once we have this flow of real-time data, we can start building solutions with it, right? So if the flow is from a mainframe and you have financial data, now you can start building some fraud analytics on that. If you're a telecom, you probably want to think about, do I have anomalous activity at my antennas, right? Like that might be something you're looking at. But effectively, the pattern we're talking about is building the data infrastructure to get data to GCP, and then you, the customer, can build the business solution that you want to build. One really cool pattern that we see a lot is using this for multi-cloud. So a lot of customers have already, they live in one cloud, but they started to think like we need to find the best of breed technologies across the clouds and use that. And in the data analytics world, that's GCP. So a lot of customers want to move to GCP for BigQuery, but the data they want to use in BigQuery might not live there. So if the data, if that's a Kafka user, we can use that exact same pattern, right? Hook up Replicator, Confluent Cloud, and GCP, and just start feeding BigQuery. So your system of record may live in a different cloud, but you can actually use that data in pretty much near real time in GCP in BigQuery. We actually have customers that are kind of doing this, right? So Unity Technologies, who GCP and Confluent had done a joint webinar with, moved from another cloud to GCP by building this bridge. And they moved to GCP because they wanted Dataflow and BigQuery. And they were a Kafka customer, so this is the pattern they used. So Sarthik, maybe you can just walk us through like how customers might use this for AI and ML.
Yeah, no, thank you, Josh. So this particular architecture diagram which you are seeing, this is an actual customer implementation for a customer in the banking space who wanted to handle a better fraud detection, more near real-time fraud detection using GCP's capabilities, but they had tremendous data gravity on-prem because they had a lot of data in mainframes, in Hadoop, in Oracle, Teradata, etc., lying on-prem. Plus, they had a whole bunch of data from different stores to like mobile devices to web, which is constantly coming in, and all the systems are set up to receive the data. Thankfully, they were already using Kafka to communicate across all these disparate systems as a message broker on-prem. And what we did was we deployed Confluent Cloud and we used Confluent Replicator, like what we have been talking about, to move some of the data to GCP. Now, as a first step, what they are doing is they are actually taking the full data, which is coming in every day, rather in near real time. As the more data is coming in, they are actually flowing into Dataflow for doing some processing, storing the full data source data stream in BigQuery. Because in BigQuery now you can do a lot faster analysis across those terabytes or petabytes of data than what you could have done on-prem, especially across all those discrete systems. And then they're doing a visualizations of the data using Looker. But probably more interesting is they are actually doing in a Confluent Cloud, they are actually sorting out some specific data streams, and those data streams they are training some fraud models, and they're actually passing it to those fraud. They're deploying those fraud models, and then they are sending those data to run on those fraud models to determine what of those transactions have any fraudulent behavior in them. And then finally, they are using actually sending the data to a Kafka topic on running on Confluent Cloud, so that they can then send back that feedback downstream to their on-prem system, so that based on the transaction being determined to be fraudulent or not, they can actually take actions on the systems on-prem. I just want to take a second and hopefully you guys will appreciate and understand and relate that this is though this particular case is for a fraud detection application, but a very similar pattern can be applied to almost every other use case from consumer behavior analysis to market trend analysis to every other business scenario which you can think of. If it satisfy the criteria of like, hey, you are already invested in Kafka on prem and you want to start leveraging the GCP services like AIML or visualizations or BigQuery, those things are immediately without having to move all the data or without having to wait for you to move all the data to cloud. So this kind of sums up the core messaging with how can a hybrid data pipeline can solve those business problems. So thank you very much for attending our session. I want to hand it over to Josh, who has a call to action for all of you. So Josh, please take it away.
Thanks. Yeah, I think what I would love is if this sounds interesting to you, please check out Confluent Cloud. You can spin up a Kafka cluster in about 10 seconds, and Confluent covers the first $200 for the first 3 months for everybody. So it's effectively free to try. Check it out. Play around with some KSQL, and hopefully you'll love it. Thanks for joining.